Okay, great. Thank you everyone for attending our panel discussion today. Our discussion is on innovation in mass timber buildings, design and construction. We'd like to welcome everyone here on behalf of CLF Toronto. My name is Anna Wang. I am a steering committee member of CLF Toronto, and just wanted to also acknowledge that today our event is hosted by DIALOG, and we are also hosting this event in partnership with the Mass Timber Institute. So a brief introduction on CLF Toronto. We're the local hub of the Carbon Leadership Forum. And the intent of our organization is to organize local events that empower professionals to reduce embodied carbon from buildings and infrastructure. So please feel free to connect with us on LinkedIn. We also have a website where we host our past event recordings and make news of our future events. So our next event is going to be nothing. I promise we have one. Okay, great. Our next event is April 9th. It's a virtual webinar. We'll be hosting it. We had a 2023 Ontario Embodied Carbon event last year where we gave out awards for certain categories. So the two categories that we'll be presenting as winners are innovation in industry and major retrofits. So please feel free to register and attend that event if you're interested. Just as a land acknowledgement for today, before we get started, I'd like to acknowledge we are on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, and the Haudenosaunee, and the Wendat peoples, and is home to many diverse First Nations, Inuit, and Métis people. It is the responsibility of all people to share in wise stewardship of this land and its resources, which leads us into our discussion today on mass timber. So our first speaker is Professor Arian Rad. From the University of Toronto's Civil and Mineral Engineering Department. The overarching theme of Professor Rad's activities is to advance sustainability, digitization in building technology, and structural engineering. Professor Rad's research is located at the interface of multi-scale experimental and computational methods. With a particular focus on structural engineering aspects, his research integrates advanced digital fabrication technologies and human-machine interactive design with eco-friendly structural materials, such as carbon, such as timber, to embrace new design frameworks and principles for sustainable structural systems. So welcome. Our next speaker is Chris Applegath. Chris is a founding partner of DIALOG and launched its Toronto studio in 2003. Did I say Chris? I meant Craig. Craig is a future-oriented thinker and passionate advocate developing thoughtful planning and design solutions that make sense in a world challenged by climate change. Since completing the studies of Graduate School of Design at Harvard University and a Master of Architecture in Urban Design, Craig has garnered a reputation for successfully leading complex sustainable planning and design projects and is internationally known for his advocacy and thought leadership in low carbon and regenerative design. And last but not least, we welcome Haley Kikero to the panel. Haley is a structural engineer and has focused her career specializing in sustainable architecture and the advancement of timber building systems. Haley spent several years of her career in mass timber research and as a structural designer with Intuitive in Toronto. She has worked on the development of affordable housing projects built with high performance timber panels, contributing to the successful completion of several turnkey housing projects such as Assembly Corp. Haley currently works as a technical manager for the Canadian Wood Council, aiding project teams in delivering successful timber projects. I'd also like to introduce our panel moderator for tonight, Professor Robert Wright. Professor Wright is an associate professor at U of T, Daniels faculty, as well as the principal of IZ, an open exploratory practice, and a director of landscape research. As both an educator and as design practitioner, Professor Wright is well positioned to lead our discussion today on cutting edge industry practices and innovation. And so a warm welcome to everybody. Thank you for attending our event today. I'd just like to welcome up Anne from the Mass Timber Institute just to share a few words on that.
Good evening, everyone, and happy spring 2024 to you. I think Mother Nature reminded us again today about who is in charge, and that sustainability, a theme of this discussion, is her domain. I'm Ann Coven, a forester, a co-founder of the Mass Timber Institute with my colleague Rob Wright and Craig Applegath, not Chris, Craig. Who has been inspirational, and the help we've received in getting the Institute up and running since 2018 has been very much what Craig has been doing for us with Dialogue. Arian Rad is one of the Institute's associates, and you'll be hearing from him shortly. And another Mass Timber Institute person in the audience is Catherine Edwards. Catherine, do you want to raise your hand? Catherine is also a forester. And she's looking into a new educational program that we're starting at the Institute. So I certainly encourage those of you who want to understand the connection between forestry and mass timber to get in touch with Catherine. And a special thanks to Michael Musa and the Carbon Leadership Forum for organizing this event. The Mass Timber Institute is located within the Daniels Faculty of Architecture, Landscape and Design at the University of Toronto. Our purpose, unsurprisingly, is to advance research and education, two crucial ingredients in the adoption of mass timber as a building material. Some of us are foresters, some of us are architects, some of us are engineers, and we represent the story of mass timber from the trees in the forest to the buildings that are popping up at a slower pace than we might like, but certainly advancing. And these are typically a hybrid of mass timber, concrete, and steel. Tonight's discussion will, I think, persuade us even more that increasing mass timber as a structural material in the construction mix is positive for a number of reasons. So I invite you to visit our website, sign up for our newsletter, listen to our Mass Timber Today podcasts to keep up with innovations in the sector. And also, I leave you with the question that many of us are asking. How can we ensure that we permanently store biogenic carbon in our cities in order to produce a durable, human-made carbon sink? Thank you. Oh, and Arian, I think that you're ready for Arian to start his presentation? Yes.
Good afternoon, everyone. Bonsoir à toutes et à tous. How many people here are architects before I start my presentation? Just curious. Please raise your hand. Okay, and how many colleagues are engineers? Any fellows from construction, contractors, builders, home builders? Decision makers from, yes, please. Decision makers. Great. Okay. Once again, bonsoir à toutes et à tous. My name is Arian Rad, and I'm a civil engineering professor at the Department of Civil and Mineral Engineering, University of Toronto. And as Anne mentioned, I'm specialized in timber engineering, in wood engineering, and development of sustainable structural systems, and development of software plugins for civil engineers, for structural engineers, and the use of digital design, digital fabrication, robotic fabrication, digital-oriented computer-assisted designs in civil structural engineering. And I've been honored to be a Swiss licensed civil engineer for 2 years before joining to Canada. I'm relatively new to your country, and started my appointment 385 days ago, basically. let me make a longer story short, then I will talk about the work very quickly, respecting the time constraints. In 30 years, our planet is going to have 2.1 billion people, more than this. Bill and Melinda Gates Foundation report of 2019 translated this 2.1 billion increase of population into the following. We need to build the equivalent of one New York City every single month for the rest of the 30 years in order to cope with this increase. On the other hand, architecture, engineering, and construction sector is responsible for 40% of greenhouse gas emissions, CO2, et cetera, that we are all aware of that, resulting into the current climate crisis or climate chaos, right? So there's an urgent need, basically, to address that. And there is an urgent need to shift the design paradigm from what we do as business as usual, hand tool technology, machine tool technology in timber engineering, for example, to something like information tool technology, how to use information tool technology, how to use digital tool technology, how to use digital fabrication, how to use machine intelligence to help us cope with this situation. It is within this context that my work is centered around what I call integrated design approach, where geometry processing, understanding the power of geometry, basically, is integrated with digital fabrication, with sequential robotic assembly or manual assembly, algorithmic aided of assemblies, of discrete assemblies, timber engineering design, mass timber using eco-friendly, sustainable, and by the way, structural engineering specialists translate sustainability into resiliency, right? Resiliency as the last element. That is called integrated design approach from my perspective. So understanding the geometry, how different elements are connected algorithmically, and how instead of adding just fasteners, just nails, screw, bolts, knife plates to two elements that we want to connect, how to understand the geometry, how to harness that, how to harness the power of form. Architects call it typology, if I'm not mistaken, right? Into something that will have, that may result into superior structural performance. And basically, after having come up with that, building your structure. Also, understanding timber, wood, its physical and mechanical performance, different types of wood, OSB, CLT, LVL, which is actually, this one is missing in Canada, to the best of my knowledge. We might not have that much hardwood LVL, which in Germans call it Baubuche. Basically, it's an 14 millimeter thick hardwood used for construction. I'm going to show one slides later for that project that we built. Digital fabrication is another element, and how to provide G-code, how to control the CNC machine, how to use that for fabricating the elements that you want to have in order to control the force flow of your system, and stories like this, okay? And of course, civil structural engineering specialists wants to break things, right? We just don't want to have a prototype sitting somewhere. So building stuff like in the connection level, then component level, then system level, then building level. That is me. I'm trying to just, this is me trying to survive. That guy, yeah, over there. Anyway, structural design, how to then translate that into some sort of equations, design procedure, workflow that can be used by engineers. Also, given that we're dealing with complicated, complex structural systems, computer-based simulations using computers and computational design. Architects mainly use computational design, but I guess one of my responsibilities and missions as a professor of civil engineering is to raise this awareness that computational design also exists in civil engineering, in structural engineering, and that can be well integrated with architecture and architectural science as well. So, for example, we have a geometry and how to translate the different ingredients, including the geometrical and mechanical properties of that geometry into a meaningful engineering model. That's been called computational design from the perspective of structural engineering. The whole intention is to change or shift the design paradigm from this scenario where we define architects, engineers, basically the first question I ask, contractors, etc., to something that is called collaborative, kind of non-siloed workflow, where we define buildings, like typical like mass timber buildings, CLT-based systems, glulam-based systems, and defining and designing design frameworks accordingly. And reflecting all of these different things under one single umbrella. I call it a community-based platform, where you, architect, engineer, you don't have to deal with different softwares. You can handle geometry. You can then run your model. You can then generate the beam model. You can send your elements for fabrication. You can do everything under one single umbrella. For example, using Python, defining object-oriented programming, using Python, defining classes and objects, and then just linking all of those together. Why not? And of course, I guess another responsibility of researchers is just to take care of all of those complexities and deliver a plugin, a framework, something functional and robust, basically, to practitioners. I call it plug and chuck, right? Okay, I talked about research. I know I don't have that much time, so I will really make it as quick as possible. Let me go through the projects that I've been honored to be involved in during my tenure back in Switzerland, and now also here, we are also trying to develop some sort of projects here. So that was a spiral that was designed by actually my former boss, Yves Wynand. And we were a couple of researchers as architects and engineers all working on the project. I will give you very like kind of list of different projects covering some sort of different complex things, but that was a small scale spiral that we wanted to design. And the architectural side of the project came up with the final geometry, satisfying the fabrication and construction, like the constraints. And my sad life was to make that functional by carrying out experimental tests and then simulating in Abacus, and then he had to modify the geometry, and then voila, we got the finalizing the fabrication process. That's that object-oriented programming that I talked about. Everything was handled under one single umbrella, one platform. We generate the geometry in Rhino. We run Abacus inside Rhino. We got the results back in Rhino. We generate building information modeling in Rhino. We send it for fabrication in Rhino. Rhino can be Blender, can be AutoCAD, can be so on and so forth. Okay? So yeah, that's a project. And another project was round wood construction, using round wood directly in construction, directly. Like it was my colleague who went on site. It was in Commune de Rosinière in the Francophone French-speaking part in Switzerland. He scanned some trees that he wanted to be like very straight. And then he took them down. He used point cloud 3D laser scanner to obtain the geometry. And then once the geometry was obtained, there's a lag, right? Then once the geometry was obtained, we finally came up with the final geometry. It was a Zollinger system, a reciprocal system, a two-layer reciprocal system. And then we wanted to establish wood-wood connections, and then one just single bolt here in order to, like a grid shell systems, basically, right? And then we will put one round wood from one to another, again scanning the geometry. And then once the geometry, everything again inside one platform. Once the geometry was finalized, then we use our robotic fabrication facility in order to build a full-scale prototype. And that was a research we presented in one conference back in 2021 in Switzerland. And another project was like a prefabricated slab system. And that length is about like 12 meters, basically. And that's the last one. I would go very fast in order to finish my presentation. I call it gigantic mass timber. And it's all about spatial timber system. This project that you see, again, the architect of the project is Yves Wynand, and he is the principal engineering in record, and a bunch of researchers, myself included. And that's been the flagship project of I believe, my life, because I'm talking about 5,800 square meter, not foot, meter, 5,800 square meter. That was the project. And it consists of 23 different arches, like as you see here. The shortest span, that one, is 23 meters. Largest one is 54 meters. And well, so far you can build it, right? It's not a big deal. But you will be amazed if I tell you that there's been not a single nail or bolt or a screw or glue or whatnot has been used in this project. I always tell him that you should be a very brave man to put your signature on that building. So again, this is one of the magics. This is one of, I guess, the second responsibility I have as a professor of civil structural engineering in Canada, is to motivate industry, architecture, construction, civil engineering, decision makers to take some sort of decisions which can ultimately lead to that kind of projects. That was not only one project. That was basically the development of a design framework that can be used and replicated from one project to another, from one site to another, from one scenario to another. And guess what? The industry partner was willing to provide cash, in-cash contribution, building a scale of 1 to 3, half a scale prototype in order to basically verify assembly, fabrication, and things like that, and full scale prototype. That was the one that I was on top of that trying to survive. Here was the prototype that we were basically testing, putting some sandbags at top and trying to verify the structural system. Yeah, there you go, exactly, yeah. Right, and then, of course, they all had their engineering record, other collaborators from industry verifying the whole design process, foundation, pedestal, et cetera, but at least our job was to develop that knowledge and transfer that knowledge basically to our industry partner. And building, so far, I believe it's been like 15 to 16 arches have been already constructed, and it's in Luxembourg. It's not in Switzerland, it's in Luxembourg. And so we try to address many different forms. Again, it's not a matter of form or geometry, it's basically the matter of the framework. So here at U of D, what I'm trying to do is to introduce two main streams to the conventional building design and technology. One is digital fabrication and digital design, and another one is sustainability-based design, basically. By digital fabrication, simply I mean the use of, for example, CNC or robots, and how they can be harnessed and used systematically and more efficiently in conventional building systems. And another one is basically introducing sustainability-based design with structural integrity, and in very particular, I mean either using it in glulam systems or in hybrid system, lightweight, mass timber, or most importantly, CLT systems. Yeah, so modular prefabricated structures can be very effectively emerge from the design framework that I talked about, and that's kind of appealing and attractive to a wide spectrum of professionals. I guess I would also include this here as perhaps the very kind of uh, pressing need of industry addressing material optimization, design for disassembly, and prefabrication, something that can be very easily, let's say, addressed by the design framework that I talked about. I will finish my presentation by this. Of course, structural engineering, architecture, construction, they look at problem from their own perspective, but it is absolutely every single of us responsibility to think about the benefits that can emerge from that work, of course, environmental impact, of course, the structural performance, of course, aesthetics, space design, design in general sense. So these are the things that I wish to accomplish within the frameworks that I'm trying to develop and promote. And all of these things will result in some benefits, let's say, reduce the travail, reduce human resources, accelerated project execution, reduce construction logistics, improving structural performance. These are basically the numbers that the results that came from our analysis based on the previous projects that I described. And hopefully we can have a better world. Let's put a big question here. But yes, so that's pretty much it. Mesdames et messieurs, je vous en remercie beaucoup. Thank you so much.
It works? This works? Okay. Hands up. Who knows what? Oh. Well, there it is. Okay. Hands up. You know what this number refers to? Yep. Okay. You guys should. You're in the carbon business. This is a really key number here. It's the sustainable amount of CO2 concentration in the atmosphere that the planet. I'm here to say our house is on fire. So we asked ourselves at Dialogue what it is we can contribute. We're just a little design practice in Canada and the States. What can we do that might have some relevance to the bigger world? So we said, well, wait a minute. What's not being talked about, at least when we started thinking about this, was hybrid structures. Mass timber was all the rage a few years ago. It still is, but it was a pure sense of mass timber. It was just mass timber, not concrete, not steel, just mass timber. How tall could you do a all mass timber building? We said, well, yeah, but you can get 12, 18, 20 stories maybe, but our cities are filled with very tall buildings. How do you do mass timber in tall buildings? And we thought, hybrid structures. Let's explore that. So as a group of partners, we sat down and we defined this as a mission in 2018. How can we design a mixed-use, high-rise building using wood, steel, concrete, and other advanced materials that maximizes the overall use of sustainably harvested wood by volume? That's locking up carbon in a high-rise construction in the most cost-efficient and energy-efficient, low-carbon and elegant manner, architects, that is also conducive to human well-being and the well-being of the environment. But the key thing here is maximizing the overall use of sustainably harvested wood by volume, not the purity of mass timber. So long story short, and if I had more time, I'd explain how we got here, but this is the result. This is what it looks like as an architectural rendering, a 105-story tower, and this is the structural diagram here. And you can see you've got a steel exoskeleton. This is hybrid structure, steel, concrete, and mass timber. And you've got concrete foundations and a concrete floor. It's what the structural engineers call a tube structure, tied together with these truss floors, but the magic is this thing here, the floor structure, because it turns out that floors in tall buildings, the floor systems in tall buildings, and this was new to me when we started exploring, is between 65 and 70% of the mass of a tall building. That's a lot. So if we could take that element, that floor system, and turn it into mass timber, it would mean we could store a heck of a lot of carbon in mass timber in a tall building, even though the tall building was comprised of a big concrete core, standard core, and a steel exoskeleton. But you could store all that carbon in a 105-story tower. Why a 105-story tower? Because I probably wouldn't be invited to speak about this if it were a 30-story tower or a 50-story tower. So we said, it better be a super tall tower because then the world will care about it. And it did. So when you start out as engineers and architects thinking about something, but you want to build a prototype that's got some reality, that has some purchase on more than other architects and engineers, builders, constructors, developers, you've got to have it made real somehow. So we decided we had to do a prototype, and we partnered with Ellis Dawn, who was at the very same time doing their own innovations in mass timber research. And they teamed up with us to design a hybrid timber floor panel. Now, if we had more time, I'd get Daria or Thomas Wu or Cam Ritchie to tell you exactly how this works structurally. But basically what it is, it's a CLT floor panel that's 12 feet wide by 40 feet long. 40 feet long, right? That's longer than typical floor panels, and that's the width that you have to have for a commercial office floor plate. And it's at the extra tension here is held by these post-tension steel rods. They run through, two of them run through each panel. So that's the hybrid. And that allowed us to design for a tall building with commercial floor plates. And this is a patent pending. Or actually, Darius, we got the patent, right? 2 countries. We're still waiting for the rest. So that's what it's going to look like. You get the idea here, but you can see the mass timber. You can also see the concrete covering of the steel because of fire protecting the steel over that. And you've got a complete clear floor. So we're here to talk about carbon, and I was told I had 10 minutes. So in compressing this, the getting to zero carbon, 3, missing an E, key strategies. First of all, you've got to reduce the energy use intensity to reduce operational carbon. So we had to reduce the amount of energy that this building needed. So really good insulation of the wall system is key. We had to meet energy needs with low carbon and zero carbon energy. So for example, the cladding on the south, east, and west of the building was PV photovoltaics. So we were generating electricity in the cladding of the building, and we also had a carbon bioreactor, algae bioreactor, to suck up the CO2 out of the trigen generator we had. And then meet the energy needs with low carbon and zero energy, which I just mentioned, reduce embodied carbon of construction, and lock up biogenic carbon. Those are the big strategies we use to get to zero carbon. Operating decarbonization strategy. Well, how do you get to zero operating carbon in a building like this? Well, key strategies are reduce heating and cooling loads, what all of you are probably doing in your buildings right now. Maximize heat recovery. So take the heat being generated out of some floors, like on one of the floors, it was a data center, so producing energy, a remaining heat, so we could suck that up and use it in other places, or store it in the ground. Deliver heating and cooling with efficient systems throughout the building. Leverage thermal and battery storage, so the battery being the earth, the ground below, for storing heat in the summer and taking it out in the winter. And then using CO recovery bioreactor to remove CO2 from gas-fired trigen. There is a very innovative company in Richmond Hill called Pond Technologies, and what they do is they allow an effluent, like a stuff coming out of a gas-fired generator, the CO2 to be bubbled through a tank with algae and high-intensity light, and the algae strips the water of its CO2, And then as a result, you don't have the CO2 coming out in the atmosphere. Then you can use the algae for various things like feedstock and nutraceuticals, et cetera. And then use PV electrical power generation. So with these things, we were able to get a zero operating carbon building. And there's a diagram of what's going on there. It would take too long to explain it, except to say, these are the tanks down here for the algae bioreactors with the trigen here. And the building was such that we could use it to also heat and cool and power their surrounding neighborhood. So the building was doing more than powering and cooling itself. So what about embodied carbon strategy? One of the things that everyone is talking about now. We found that as we looked at the average information coming back from buildings of 1 to 6 stories, and then 7 to 14, and 15 to 25, and more than 25, that you had embodied carbon stored in different areas of the building. So, for example, in the 1 to 6 area, the reds and the oranges, it's mostly in the structural foundation and an envelope enclosure. But in buildings more than 25 stories tall, look at this, green, green structure. So most of the carbon is being stored in the structure of the building. So us affecting 60% of that structure with mass timber really has a huge impact on potentially lowering that carbon. And this is what our LCA produced in terms of an analysis of how much we could reduce the embodied carbon of the building. And look at these two numbers. We get a 9% reduction in the overall embodied carbon of this building because of the mass timber if we don't count biogenic carbon. By the way, everyone, hands up, know what biogenic carbon means? Okay, there are a few people shaking their heads. Biogenic carbon means the carbon that's locked up in cellulose, the wood fibers of wood. And to give you a sense of its magnitude, if you took 1 cubic meter of wood, it would be equivalent of 1 ton of carbon dioxide. So for every cubic meter you're storing in mass timber, you're locking up a ton of CO2. So that's not counted right now in just the embodied carbon. In other words, all the carbon that's produced by cutting, moving, fabricating, etc. But if you count the biogenic carbon, then we reduced our carbon, our total carbon footprint by 46%. There's a big debate in the industry right now about whether or not you should count biogenic carbon. And the argument against counting biogenic carbon is that, well, the wood in your building in 20 years, the building might be torn down and the wood put in some sort of landfill, and therefore it would produce CO2 and methane when it's digested by bacteria, and that goes in the atmosphere. Well, fair enough. But I figure in that 25-year period, if we haven't figured out climate change, we are totally screwed. So I think we want to take the risk on really focusing on biogenic carbon and argue about whether or not in 25 or 30 years it's going to be back in the atmosphere. Most of these really beautiful carbon mass timber buildings, wood buildings, are not going to be torn down in 25 years. But I think 25 years is the period of time we've got to make big changes. So, impact of mass timber structure, 2 key takeaways. 1, in tall buildings, structure represents a higher percentage of embodied carbon. That's worthwhile noting as you're designing. Like, structure is very important. So mass timber as a potential structure is very important. And a significant reduction can be realized by using mass timber. And then getting to zero carbon, 3 key strategies. First, reduce the energy use intensity to reduce operational carbon. Energy use is really, energy is a proxy for carbon. In Ontario, our grid is pretty clean, but nevertheless, you do want, as far as possible, reduce the energy, not just because you're reducing carbon, because it allows you to do other things like use electric boilers and heat pumps in the system. So you have to have a pretty tight building in order to do that. 2, meet energy needs with low carbon and zero carbon energy. This is going to be key. And then 3, reduce embodied carbon of construction and lock up carbon in mass timber biogenically. And that's it.
Okay, thanks for having me tonight. It was great hearing from Craig and Ariane about some innovative digital strategies and physical mass timber elements that are becoming available to us. My name is Haley Cuquero, and I'm a technical manager with Woodworks Ontario. And I'm going to talk a little bit today about what the Canadian Wood Council is doing to advance opportunities for mass timber buildings in our country. So you already heard a bit about my bio earlier. I'm a structural engineer with an architectural sustainability engineering background, and I've done a lot of research and working in the construction field of mass timber buildings as well. And I am now working with the Canadian Wood Council, which, if you're not familiar, we like to refer to it as a national Federation of Associations, which basically means that our members are made up of forestry associations, lumber boards, forest products manufacturers across the country, and our staff represents them in many different activities, one of the main ones being codes and standards participation. So they sit on lots of different codes and standards committees to advance the opportunities for wood and mass timber in our building regulations. And they do that, they support that with research programs as well that we participate in with different partners, which I will talk about an example of in a little bit, and produce technical resources as well for designers and other stakeholders. Woodworks Ontario is a program of the Canadian Wood Council, and we have programs all the way across the country, so we can support projects from BC, the Prairies, Atlantic, and in Quebec with Sicobois. Woodworks Ontario is myself, our executive director, Stephen Street, and technical advisor, Brock O'Donnell, and we're basically here to increase the market share of mass timber and other wood products in building structures, and to do so through providing technical resources, direct project support, tours, workshops, all this kind of activities to educate and increase the capacity for Ontario and the country to produce these mass timber buildings. Just to add a little bit of context to the discussion, I wanted to highlight some key milestones for wood construction in Canada. So about 15 years ago now, the BC Code was the first provincial code to allow for 6-story tall combustible construction, and it took about 6 years after that for the rest of the country to get on board. So Ontario finally adopted that in 2015. And now, just in the last couple years, the National Code and Ontario Code has allowed for up to 12 stories with this new type of construction called encapsulated mass timber construction. So while you can go up to 6 stories still with light framing and or mass timber, up to 12 stories within the codes, you can now build with mass timber construction with a few restraints. So you can only do this in Group C, which is residential, and Group D, which is office buildings. Within the code, you can always make changes with alternative solutions if you go through that process. But you can build up to 12 stories with these occupancies. You can have some mixed use on the bottom floors, which is important for these projects to be feasible to be built in our cities. But you have some restrictions, like the top floor can only be max 42 meters from the first floor. So you have a hard height limit. You have sprinklers and 2-hour fire ratings, maximum building areas, and a maximum amount of exposed wood inside these buildings as well. So a large portion of these being embedded into the code was that you have to cover up a lot of that timber, and a lot of people don't want to do that when they're putting all this beautiful wood products inside their buildings. So for example, currently in the code, you can only expose up to 25% of your ceilings in suites. So a lot of people are trying to kind of go beyond that, and some of the Wood Council's work is supporting that. Just to, again, add a little bit more context, I wanted to put some pictures of some beautiful mass timber buildings in Ontario and mostly around here in Toronto. So we're seeing business cases for mass timber residential projects coming in. The top middle there is an office project. This is T3 Bayside down by the water, which is becoming a more common typology. It wasn't allowed in the code at the time when they built it. they went through alternative solutions and helped pave the way in Toronto for buildings like this. But now that we're seeing this kind of typology coming up more and more, and institutional buildings as well. So these are still currently outside of the code for building as tall as these buildings are. We have the U of T Goldring Center in the middle, going up to 14 stories, which is under construction, and Limberlost, which is the George Brown College building down by the water as well on the right. So these projects are just showcasing how we're really pushing the envelope with our mass timber buildings already. We're creating innovative solutions to increase spans, increase opportunities. The Limberlost project is a really great one to highlight because they were able to get some funding from NRCan and their GC Wood program to do some upfront testing and proof of concept to get to this scale of building. We have some of the biggest mass timber columns in the world right here in Toronto. And they, through the GC Wood program, are making a lot of this information available to other project teams to learn from or even potentially replicate. So now I'm going to quickly touch on one of the research programs that the Canadian Wood Council undertook to help support some advancement of our codes, which is the mass timber demonstration fire tests. This happened a little over a year and a half, almost 2 years ago now in Ottawa, and was the biggest mass timber fire testing done in the world that we know of. So they built a 2-story mass timber structure with products from different manufacturers across the country and had different stakeholders like fire services, building officials, insurance companies all come together and kind of design these tests so that we can investigate the behavior of a fire in these mass timber buildings in the final condition if we're going to expose more timber. So for example, these tests really looked into what if we expose 100% of the ceilings instead of only 25%? What does that look like compared to what's allowed in the code right now? And then they also looked into some construction fire safety situations as well. So what would happen if a fire event happened on a construction site before the fire protection was installed? So this was all to just generate data and comfort around how are these buildings actually going to perform? And turns out they actually perform quite well. So the 2-story structure was split into 4 different components, 3 residential suites on the 2nd floor, and then 1 open concept office type occupancy on the 1st floor. So you can see that there's some CLT walls in the middle and the back as well. That was an exposed CLT shaft wall that they left completely exposed as well to see if there would be any adverse effects inside the shaft after the fires. So we did light this structure on fire 5 times. And I'm going to show you just one quick photo of the first test that they did, which was the 1st floor open concept office. They filled that compartment with different furniture loads to represent what would actually be in a real office. And then this whole thing was enclosed with steel stud walls and representative windows and stuff like that. So they lit a fire in the 1st floor and it was allowed to completely develop and reach flashover. And they designed these tests as a worst case scenario with absolutely no fire service intervention. And after less than 20 minutes, all of the fuel inside the compartment had been consumed. The exposed wood got a nice char layer on it that was protecting all the wood behind it. And the fire went out on its own without any fire services coming in. And they left it for another 4 hours just to make sure it wouldn't start burning again. So all of the spectators that were there, I think there was over 100 people that came out to watch this test. And they were all amazed at just how this building was able to stay stable and solid. After all 5 tests, there was a total of 19 hours of fire exposure inside this building. And they didn't really account for how tough it would be to take it down at the end of the test. They were like kind of shocked at how stable it still was. So yeah, really good results. There were no adverse effects in the CLT shaft either. So again, that wall was exposed, no temperature increase and no smoke got inside the shaft. So also just to show the safety of using mass timber elements as egress or exit shafts for buildings. So quickly, I'm going to go through some of the code changes that the work is supporting and that the CWC staff are working on. The first one that has been approved for MBC 2025 is a height increase. So I mentioned that hard limit of 42 meters. That's actually increasing to 50 meters in the 2025 code. And just to allow for more flexibility with floor-to-floor heights, which will be a welcome change. We're also it's also been recommended to approve the changes for 100% exposed ceiling options. So in 2025, we should be seeing an option within the code to expose 100% of your mass timber ceilings within your suites, as well as some more flexibility with what kind of mass timber walls you can expose. So currently there's some restraints on where you can place them. It's still going to be restrained, but a little more flexibility in terms of where you can put them and how much. And another one that's still under a bit of review, but is likely to come into effect in the National Fire Code in 2025 is different alternatives for construction encapsulation methods. So this also came from or is supported by some of the construction scenario tests that they did, and just trying to get some other options for contractors to be able to make fire safety plans on their sites during construction without having to put up temporary gypsum that's not going to be there in the end condition, or put up gypsum that's not protected and gets damaged and stuff like that. Beyond 2025, there's some code changes that at the national level are being looked at for 2030, but there's also an interprovincial coalition trying to fast track some of these updates because we don't want to wait for the 2030 code cycle and then to trickle down into the provinces. So Ontario is part of this coalition to try to get some of these changes to align with the IBC more quickly into our provincial codes. So allowing up to 18 stories. And by the way, this just finished public consultation for Ontario. So some of you might have commented on that, but we had some fairly positive reviews and it's still kind of going through that review process at the moment. So yeah, up to 18 stories instead of 12 where we are now. We're looking at up to 8 and 9 stories for these residential and office buildings without any encapsulation required on the structure. And we're looking to expand this to other occupancies as well. So retail, assembly, care occupancies, industrial, all different types instead of just restricting it to those two. And finally, looking at some more flexibility and options for combustible cladding. Really quickly, I just also want to touch on some sustainability code updates that are coming in the pipeline as well. The 2025 NBC is also looking at introducing some operational carbon targets into the code, and 2030 is very early days in the code cycle, but looking at potentially adding in some embodied carbon targets into the codes as well, kind of similar to how municipalities have been introducing that, getting that into our codes so that new builds have to meet certain energy performance standards and embodied carbon standards. And the reason why I touch on this now is just because having that in our codes will hopefully create more opportunity for project teams or developers to consider wood as a sustainable alternative to meet these targets. So yeah, that's it from me. And I think we're going to move on to the panel discussion now. So thanks.
Don't have to hit a button. So we're going to start by I'm going to start by asking some questions, some pre-approved questions, as they say, and then we'll open it up to the crowd for you people to actually ask some questions as well. So the first one, I'm going to start with you, Haley, since you ended first and you did all the code stuff. Is what advancements has mass timber? What's the biggest advancement mass timber has made over the last few years? You were showing us the code changes, and secondly, what are the biggest innovations you see from your perspective, looking back at the construction, that things are coming forward in the mass timber industry?
Yeah, great question. Thanks. Yeah, so as I mentioned, there's been a lot of code changes over the last couple of years, especially that'll hopefully encourage more of these mass timber buildings to come out. I saw a stat the other day that said a couple of years ago, I think worldwide there were maybe about 140 mass timber buildings total over 8 stories. And now currently there are like thousands of them in planning and development. So I think just by nature of volume, we're going to see a lot more creative solutions coming out. And also just, I think the crux of it is repeatable solutions as well. Because, the more we build mass timber buildings, the more we're going to see the demand rise, the supply rise, and the cost competitiveness really emerge. So yeah, I think we're building a lot more. The advancements in the codes are really, I think, groundbreaking for the number of buildings that we're seeing because we're removing the barriers of alternative solutions. We're still seeing, the examples that came out that are doing these really innovative projects with alternative solutions, but having them codified kind of removes the onus on the design teams to prove or demonstrate the safety protocols for each building. And it removes the onus on the municipalities to have the expertise in-house and the comfortability to review those solutions and approve them. So I think having the code changes to codify these solutions are really going to be one of the biggest factors advancing the opportunities for mass timber buildings, just because we're making them a lot more accessible. And then, recently in the last month or so, we've seen like half a dozen announcements of mass timber producers around the country expanding their capabilities, opening new facilities. So I think just with sheer volume, it's really going to push the envelope to advance mass timber buildings, and in turn, getting to use all of these nice innovative solutions like the hybrid panels or the Limberlost and other GC Wood funded buildings that are kind of becoming public knowledge.
So Aaron, from your perspective, the same question, but from the Europeans' perspective, since you bring that to us the best here.
May I ask what was the question?
What advancements have been made in mass timber in the past few years, and what new advancements do you see moving quickly forward?
Okay, I'm absolutely biased to digital design and digital application for sure. But based on my limited experience I had in Europe, I can pitch it that way. The risk threshold, the amount of risk that industry want to take and want to collaborate with academia on some high risk, high reward projects is much more pronounced in Europe than, at least to the extent of my experience and knowledge, in Canada. On the other hand, the support receiving from government is much more in Canada than Europe. I believe so. For example, do you know through national, well, I'm not also good with acronyms, NSERC, which is National Science and Research Engineering Council, they have different modules, and they can support up to 67 to 70% of the projects that can collaboratively be designed by industry and academia together. So if you have an idea, if I have an idea, if you want to work and address a challenge, pressing challenge that you as industry have in your day-to-day business model, and I see some scientific value, government is going to support that, right? So to me, the level that actually industry needs to, the level of risk that industry needs to take is one of the key and most important factors. Another thing is for sure infrastructure, technology. 6 years ago, 7 years ago, when we were talking about CNC machinery, perhaps metal industry, not necessarily construction, not necessarily wood or timber. Now, especially in Europe, as I worked at EPFL in Lausanne, the population is 100,000 people. In a city with one population of 100,000 people, you can find almost 10 centers of CNC 5-axis digital fabrication. I believe I already had a bunch of difficulties finding 2 or 3 centers in Toronto, right? So having that infrastructure in Canada would be another factor. It's happening. Like, I'm talking to some shops, and they're saying, yeah, this is in our plan. We are going to be equipped with that technology in 6 months whatsoever. So this is something that actually it's been already happening in Europe, and it needs to be fostered, promoted, and accelerated actually in Canada.
So I'm gonna pass it to you, but from the perspective of a practitioner who's actually making these buildings, what do you think the need are in terms of these to get this biogems to make it a much more day-to-day reality?
So what are the needs of practices that want to push the envelope on getting biogenic carbon going? Well, I would like to think that we would have some impact on the world as to whether or not biogenic carbon will be taken more seriously. But I'm going to turn it back to you, Rob, as an academic, and say that this is not about practitioners just, it's about practitioners, the academe, the universities, colleges, all saying to policymakers in Ottawa and the provinces, this is really important. You should encourage this or punish other behavior that doesn't encourage it, carrot and stick, because this is a policy decision. I think we all know that biogenic carbon is important, locking up carbon is important, and every decent architect and engineer knows how to do it. I mean, mass timber is no longer rocket science, but there's got to be some sort of inducement for the industry to go that way. Right now, mass timber, I interviewed Mark Gallioni on the Mass Timber Today podcast, and he talked about the decreasing cost differential between mass timber construction and comparable steel and concrete construction. And it started at like, and you remember, like 15% and then down to 12, and then finally it's now around 4% greater. And we've just started really in terms of the number of buildings out there. In 2 or 3 years' time, it will probably be zero delta, hopefully. So I think that will reduce the friction of the industry in adopting it. But then there's got to be some sort of push, I think. So I think we all should be, if you're speaking to your politicians or policymakers, if you know them, like, talk about biogenic carbon. I mean, if you're in the business of building with mass timber, biogenic carbon is really important because it locks up carbon, and we're in a climate emergency. Like, it's serious, and it's one of the tools that we have of locking up carbon. So I'm not sure if that answers your question, but it's not like practitioners, it's all of us in different sort of sectors and roles in society understanding its importance. And Mass Timber Institute, by the way, is a really good place to sort of broadcast that.
One of the things, I don't know if most people realize it, but that the provinces of BC and Quebec have a wood first policy.
That's right.
In their provincial government.
There's a good policy.
Yeah, that's right. And that policy means if you're making schools or arenas or other types of buildings, that wood is the preferred material to start with. So other than in Ontario where we have to prove after steel and concrete that it's good, that's a real difference. There's a policy thing, and that's why those two provinces are way ahead of this game relative to the amount of development and facilities for this type of wood.
You know, I should have just said you should answer that question.
Yeah. No, but one of the things that's funny, Anne and I have talked to the Finns. You know, if you want to talk to you talk to the Austrians, you talk to the Finns about wood. The Finns look at us and say, like, why are you Canadians not the best in the world in this? Because you have they said the province of Ontario has some of the best spruce, pine, and fir in the world, and you're just selling 2x4s to Americans. Like, what are you guys doing?
So,
like,
the classic example is in the 70s, there was research done in Canada, university research about how to make an airtight building. And we did nothing with it. And the Germans took it and gave it a cool name, Passivhaus. And all of a sudden, it's cool, and we're doing it. But it had to be Europe that showed us that this was a good thing to do.
So my next question is, Haley, for you again. Because you again, you see this almost every day, what are the key friction points that are happening right now that are kind of slowing this development? Because we see it moving faster and faster, but still, as you know, there's a lot of conversations around supply chain and availability and the cost and the fact that it's cheaper to buy wood from Austria than it is to buy it in Canada. What do you see? Hey? Yeah, insurance. Okay, fair. Well, I have insurance down here somewhere. But anyway, yes. So if you may comment on some of the key issues that we're facing.
Yeah, sure. Yeah, I think insurance is definitely a topic that we are looking at at the Wood Council, at least, kind of trying to talk to insurers and figure out what those barriers are. Building officials as well always need some training to kind of get up to date into what they're willing to accept. I think maybe some of us in this room see a lot of stuff through the lens of Toronto, but in smaller municipalities throughout the province, we still see some friction when it comes to innovative solutions using mass timber. So educating our building officials. And really, you said it, supply and demand is another just friction point that we're working on. Like I just mentioned, there's been tons of announcements over the last few weeks of expanding our capacity to produce mass timber products across the country. There's new facilities coming up, which will reduce transportation, sort of risks to ordering mass timber from one side of the country to the other. So yeah, I think working on our production is one of the issues at hand that is really being focused on right now, and that will help ensure the cost competitiveness to mass timber keeps coming down as well. Yeah, so I think that's everything that I wanted to say.
And I'll turn it over to you, Craig. What are the kind of sort of frictions points you found as somebody trying to advance the use of these buildings?
There's a number of key friction points. We've been doing mass timber projects here for about 12 years, and the friction points are becoming less and less of an issue. But the first one is general understanding in the overall construction and approvals industry about what mass timber is. It requires more thinking about a new thing. Trades have not necessarily done it before, so there's more limited number of trades that have the expertise to do it. That's gradually changing. The plans examiners haven't always looked at mass timber drawings before, so they're loath to run them as quickly. They run them so quickly through now, but it takes a little bit longer because of the time required. Clients are a little bit nervous. Architects and engineers will sometimes say, well, it's $100 million, and what's an extra couple $1 million? My answer to one of my team would be, well, can you write a check for $1 million tomorrow? What happens if our clients make a mistake? If we make a mistake, we get fired. If they make a mistake, we get fired from the job. They get fired from their job. So there's a real worry about anything that departs from the norm, and why risk it? So you've got to have someone in a senior decision-making role at an institution or a private enterprise has to make a decision it's going to be mass timber, because otherwise no one below that really wants to make the decision on something new. Other friction points, just finding, you don't find people, team members for your engineering and architecture team available. You have to train them. Now that's changing. Again, all these things are, as mass timber becomes more common, are changing. But there's all the things about being new are the things that cause friction points.
Arian, my question for you is, one of the holy grails that we've been talking about in architecture and design and construction for about like 100 years is modularity, and being able to assemble things in a kind of modular way, as being the kind of, the repeatable, the usable. The challenges are, at both ends. One is one of design freedom. As designers, you want to have as much freedom to program your space as much as possible. And at the other end, if you're in the construction industry, you need to have a freedom in terms of assembly. Everybody's not going to have robots working around, so it has to be able to be assembled in several ways. What has been your experience in terms of meeting that challenge? This is again another sales pitch you can make for.
I cannot answer that. It's a really challenging thing. It's really a challenge. Addressing degrees of freedom in designing the space, and in the meantime satisfying, and I'm not talking about structural engineering here at all. Addressing construction constraints and assembly constraints simultaneously. It's a really challenging thing. The thing is, okay, I can answer that. The thing is, And that's sad. But currently, mass timber construction is really project dependent. The constraints you have, unless you're dealing with very regular, standard, predefined geometries. Otherwise, the constraints that you have in construction, in assembly, in fabrication, let alone in structural engineering, is different from one project to another to some great extent. That makes modularity challenging. On the other hand, modularity, well, it's a very big kind of claim if I say that, but mass timber is the best candidate for modularity on the other hand. So, with all due respect to practitioners in construction and steel construction, modularity can happen with timber and mass timber specifically. But how to address space constraints and fabrication in a kind of generic manner, I cannot answer.
I'll speak to it because we've been involved in a couple of modular building projects. And I think one of the key challenges is if you're doing volumetric modular. And volumetric modular means you build the suite as a complete unit. So everything is there. It's got a floor, walls, and ceiling all as one unit. And one of the challenges is the cost of the extra. You get an extra floor or ceiling because you're stacking a complete unit on top of another unit. So instead of having one floor, you have two. You have a floor and a ceiling. So you've got an inherent inefficiency there. And I think one of the other challenges is right now the same friction point I mentioned before is you don't have an industry that's set up to competitively compete to do it. So whereas you would have a whole bunch of potential efficiencies from creating a unit and doing it again, this is volumetric, you don't have the competition there. However, the other kind of modularity is not the volumetric modular, it's the elemental modularity. And I think there's probably more potential in that. And that is, for example, you have the walls, the floors, and the possibly some of the key units like the kitchen unit and the bathroom unit modular, and then you come on site and you put them together. And that requires less sophistication of the industry, it seems. Element 5 has done it, they say, cost competitively on the YWC, I think, in Kitchener. So I think there's, and it's also easy to ship there. It comes as a flat pack and they open it up on site. So I think there's different kinds of modularity. By the way, stick frame construction is modular construction. The module is 2x4s, right? And 2x8s and 2x12s. So there's a sort of a range of what is modular. But the key thing is being able to fabricate as many of the pieces off-site and bring them to the site and assemble them quickly. And one of the really lovely things about mass timber, by the way, how many of you have actually done or worked on a mass timber project before? Hands up. Okay, so isn't it one of the cool things about it where you come to site and there's nothing there and in 2 days the thing's up? Like it goes up really fast because all the pieces, even though it's not modular, they come as all the columns come and they get put down and then the beams come and it goes, and then the CLT, and it's fast compared, and it's quiet and it's clean. So, you know, there's a whole bunch of things there that even though it's not called modular, it's because it's all those pieces, those big pieces are being manufactured off-site, brought to the site and assembled. It makes for sort of a second tier modularity.
I think I can now answer your question, Rob. More than what I believe in modularity, I believe in prefabrication. Give you one example. For that arc that I show, one of them, the largest one, sorry, the shortest one, consisted of 600 bespoke timber plates, 600 individually unique timber plates. Each timber plate had minimum of 8, maximum of 12 connections. So we are talking about approximately 12,000. And by the way, the geometry of each connection was different. We're talking about something between 10,000 to 15,000 number of wood-wood connections with a unique structural performance. There's no modularity here at all. Everything is bespoke, individually, uniquely defined. But prefabrication helped us to construct that gigantic building in half a day. Half a day. So I would say maybe modularity would be something very cool, very great. If there are some business models, workflows developed for that by companies, by universities, yay, fantastic. But I believe in the power of prefabrication.
Yeah.
Absolutely.
Is that okay? Yeah, fun question. Yeah, I think it also depends a little bit on terminology and how we're defining modularity. Like if we're talking about prefabrication or if we're talking about panelized solutions versus volumetric, there are nuances there for sure. But from my perspective, working on all different kinds of modular projects, the key factor to making this successful and working with all of these competing constraints that the different stakeholders have is getting everyone on board and aligned early. So different project delivery methods like IPD become super important, or collaborative delivery models that take a lot of investment upfront. But mass timber does lend itself very well to this type of design process, and that's what we've been seeing on a lot of these projects, that you get a lot of collaboration up front. You are able to produce these panels to a high level of precision offsite because you get that high level of coordination, and then you recoup some of the costs on site when it goes up really fast and when you don't get a lot of change orders because you've thought everything through. So I think there just needs to be a shift in the project team's thinking from the outset that we're going to have to invest up front. We might need to look at some different financing models in order to do that, and kind of, put ourselves out there. But I think that's how we see real efficiencies with modularity in whatever form you're talking about.
I think one of the things in talking again to the Europeans, they rarely believe in what you're talking about, Craig, in terms of, they call it micromodularity, element-based modularity, because of having the design and the assembly freedom. That what can a human being put together, and what can you actually design in different things. I was just talking to a former student in Denmark, not Denmark, but in Holland, and he was showing me all the school buildings that are built in modular assembly processes and expanded. Some of them have expanded 3 times now for uses, instead of putting the portable outside, they can actually expand the whole building. And they've worked out all the dimensions required for those spaces and the kind of magic points of those things, almost the way you would use Lego. So that's, it's a kind of fascinating area of exploration, and it really requires innovation. And one of the things you'll notice in some of the Canadian literature that's come out, we're falling down in innovation. We're not innovating as much in Canada as we should be in terms of some of these new areas where we should have a higher level expertise. And this is where the academic, business, practitioner model has to be repaired in some way that's been so siloed. But anyway, I'm going to open up to other people to ask questions. Do we have the magic cube?
Yes, I think so.
Cube?
Yeah, okay. So this is a microphone. You can speak into it. I think I saw your hand.
You can't hurt
up
anyone
first
with it,
if you
yes.
want to start us off. You kind of have to hold it close to your face. It's a microphone.
Yes, it is a
Now it
microphone.
works like this. I don't see anything. Do you hear me?
Kind of. Maybe just speak loud also.
Here. You can have
There.
Yeah, and you can hear this. You can have it.
I don't want to be. All right.
Thank you very much for your presentations, and thank you for Dialogue for creating this event. I have 2 questions. First is from Haley, and as an internationally trained architect, I really enjoyed all the 3 of your presentations. And from Haley, I like to ask, what do you mean by not encapsulated timber? Because I don't know what is encapsulated timber that you told your plan to make it in encapsulated, if that's the term.
Yes, great question. And Yeah, I apologize. I had to rush through a lot of that code information because of the time constraints. But encapsulated mass timber construction, as it's defined in the code, is basically mass timber elements of minimum dimensions that are protected by some kind of other assembly that protects it from fire exposure. So it's basically materials that you would attach. The most common is gypsum, like 2 layers of gypsum board is what the code prescribes currently for the encapsulation rating you need to prevent the mass timber elements that are protected from being involved in the fire for whatever duration of the rating is that's required. So when we talk about needing encapsulation, it's about needing to protect the timber elements behind them versus having exposed timber elements that are allowed to get involved in the fire, and they're allowed to char at a really predictable rate. And then they achieve their fire resistance through developing that char layer and protecting the timber behind it. So there's kind of 2 methods of using mass timber to get your fire resistance. In the unencapsulated version, that's just referring to basically lowering the required amount of protection you have to do of the timber in that building and allowing it to get its fire resistance through its own protective char layer.
Thank you. Thank you very much. And my second question is from Ariane. And I really liked those huge arcs that you showed. And all the time I was thinking, oh, wow, how is he going to make this into like modular, repetitive thing that we have in housing? Because in housing, you have plans that repeat on top of each other. You don't have a large span that's used for example, exhibitional space or public space. You should go into floors. And that's what I think there was in one of the questions. So I want to ask, how do you feel this gap regarding your previous experience and your current experience and your current research, and what challenges you're facing? Thank you.
I do not know what future holds, but if we meet each other next time in any other conferences, we're going to talk about that as well, because this is the ongoing research that I'm carrying out right now, making a long story short. So how to move from bespoke mass timber to prefabricated, predefined, I'm avoiding the term modular. Mass timber is something that I'm currently investigate, basically, how to basically use those technologies that I mentioned in a systematic manner, and not necessarily project-specific cases. Yes, we are working on it.
Yeah, thank you. Because it's not a curve that has modularity and like the number of joints and other stuff, because you will have regular standard predefined geometries, as you mentioned.
Absolutely, exactly. Yes, that's a challenge. Yes, of course. Yes.
Good luck. Thank you.
Yes, I have a question. It's Gil Penalosa. My question is, what's missing for mass timber to really take off on the 6 and 12 stories? We don't really need any of those 110 floors. Maybe it's good to get invited to events to talk about it, but hopefully I mean, if we just do 6 floors on all arterials in Toronto with buses or streetcars, and 12 floors in the ones with subway and LRT, we would open up space to double the population of Toronto. So we don't need the gigantic buildings. So now that is approved 12, what is the missing ingredient? Because we could really solve the housing crisis as well as create a really nice city. But is it labor? Is it wood? What is missing? Oh, and by the way, when people talk about the cost of the land, well, if people know that along Bloor, they can do only 12 stories, then they're going to price the land based on 12 stories. But if they think that eventually they can do 110, then they're going to price the land based on 110. But if we were able to do that, we would be doing both, solving both. And it's already approved. So what's missing for this?
I think in answer to your question, Gil, first of all, I agree with you 100%. We don't, at least in Toronto, given we're moving into a climate crisis, tall buildings are a challenge for resilience because, for example, you have a severe heat event, and it takes out transformers and the power goes down. When you're in a 20-story building, you have no electricity, you don't have any cooling, you don't have any water, so you can't cook, you can't use the bathroom, you can't get water, and you've got to go up and down those stairs. So there's a real challenge in tall buildings. The reason we designed a tall building is there are certain cities in the world where tall buildings are what they do, and you have to figure out how to do it. I went back to a grad student reunion at Harvard, and had lunch with Richard Krauss, my professor there, and we were talking about your point exactly. And I was arguing that, you know, city buildings shouldn't be any taller than 8 to 10 stories. It was more resilient, more sustainable. And he said, yes, Craig, but, he was an academic, but what about those cities like Singapore or Shanghai, where the density of the city requires tall buildings? It's a different culture. Are you going to deny them the opportunity to have a tall building? So I thought, okay, so not only do we have to understand where you have lots of open space and you can do anything you want, therefore, the City of Toronto should have a limit of, I think, like 8 stories. Like Europe, like those are perfect buildings to live in for many, many reasons that I could go on for hours about. Agreed. But at the same time, I think the reason to do a tall building like the 110-story tower, it wasn't just a flippant thing to do. It was to say, you can do 110 stories, then you could do 30, or you could do 8. So it was a proof of concept. But you are absolutely right. The city building typology in North America, we would be well served if we could somehow limit ourselves to that 8 to 10. I'd say 6 to 8. But again, cities are now creatures of the province. And so whether or not we want to do it, it won't be up to us right now. It's up to the province. So if you want to change that, then you have to vote in a provincial election to affect your city government. Well, this is way off topic from mass timber. But yeah, there's definitely a policy challenge there.
David McMillan with the City of Toronto. Not going to go into the issues with zoning, but question for Haley. Working on several mass timber projects, 4 to 12 stories, and what we see beyond the 6-8 story range, you get into a hybrid in terms of the core versus, and just because of lateral loads, and then there are some structural requirements in the OBC Part 4 above that 30-meter height. Curious about innovations, either in technology or in the code, perhaps other changes that you might see to enable pure mass timber buildings up to 12 stories that are also cost effective and repeatable. If you have any thoughts on that. Yeah.
Sure, yeah. Yeah, I think there's always ongoing testing of different timber lateral system options and increasing the opportunity for them in the code. There's some ongoing research with FP Innovations on how taller CLT or other mass timber panel lateral systems or shear walls would perform, and kind of hoping to eventually get more of that data or more options for timber lateral systems into the codes. So yeah, I do think there will be more expansion of that, and obviously it depends on what kind of a seismic region you're in, what's actually going to be feasible up to 12 stories. I don't know that it will be feasible up to 12 stories all timber, and I also don't know that it should be. I think we need to use all materials to their strengths, and I would love to see more wooden buildings, but it's like exactly like Craig said, like we want to make these buildings feasible as well, and to your point, cost feasible. So why not get as much timber into the buildings as we can and use each structural material as it's most efficient? Because using a ton of wood where it's not the most structurally efficient, instead of using a small amount of maybe steel, for example, might not actually be the most sustainable solution just because it's wood. So I think there's a lot of levers to pull. And if you're looking at it from a sustainability point of view, all timber might not necessarily be the most efficient solution. But so yeah, to your point, I think there's definitely expansion of going taller with all wood. But I think we also have to keep an open mind for hybrid structures and using each material where it to its strengths, I guess.
Anyone else?
Yeah, exactly. I have like 12 questions, but I guess one question I would ask. And this is, I mean, for the panel, and I would include Rob and maybe even Anne in this, is, you know, and speaking to the gentleman's question about sort of what are some of the challenges, and this is around supply, right? And so, you know, Haley's talked about how, you know, we're hearing about plants expanding, et cetera, et cetera. We had a project at the university a couple of years ago where we wanted to use so much mass timber that when we talked to Nordique, they said we would have to take up their plant production for 6 months just to give us enough timber to build the thing we wanted to build. And that actually ended up being cost prohibitive. And then COVID happened and things went through the roof. And unfortunately, that project is not using mass timber anymore. But it really highlighted some of the limits we have on supply. And I think, and I kind of, from a forestry perspective, I'm interested to hear a sort of how do we tap into the spruce, you know, pine, fir that we have here? And where is the sort of industry, academic, construction innovation that we can find? And sort of, and I'd invite other people in the room who have this expertise to speak to it too, but maybe Anne can start it. Yeah.
Thank you. Thank you. I'm a forester. I've never worked for the forest industry, so I can't speak on their behalf. I don't know if Haley wishes to take a shot at it, but we have some, we take some pretty firm stands at the Mass Timber Institute when it comes to wood supply. And I think tonight is an example of the kinds of ethical conversations we're expecting architects and engineers to have when it comes to mass timber. I'm sure none of you wants to have a mass timber supply chain that endangers boreal woodland caribou. You want to be able to source wood that helps regional economies. We would put a premium on wood that's being harvested by indigenous remote communities. So there are a variety of social and politically responsible aspects of the wood that you select. So unlike concrete and steel, which you're used to just arriving, I understand, at the work site and there it is and you build with it, I'm finding that your professions fortunately want to explore more deeply that in fact you are using a sustainable supply. So that would be the first thing I would say about the expectation around using more mass timber. If we thought mass timber, for example, would, if everybody's going to go out and build with mass timber and cut every tree in Canada, not going to happen. The concern about of growing, burgeoning mass timber industry across the world is really applied to the tropics, where there's a concern that scarce agricultural land would be made into a plantation forest to provide wood supply. That's a responsibility we have as users of wood. We have to be worried about those problems and avoid them. I don't think we have that kind of a situation in Canada, and at the Mass Timber Institute, we are exploring all of these kinds of issues with Catherine's taking on a project to work with architects and engineers on some of these questions, because you're not raising them only yourselves. You have to answer questions for your clients. You have to talk to environmental groups. You have to be comfortable and knowledgeable about the materiality of wood in mass timber structural wood. So I don't know if that really answers your question.
Well,
Adrian.
I mean, from the perspective of, you know, from the perspective of responsibly managing our forests, we have quotas for how much we mill, right? Are we, and this is just from managing our forests, and this is speaking for the Ontario context, are we at this point meeting those? I mean, the fact that we're selling 2x4s to the state is a problem.
We've done that for 120
I know,
years.
because it's,
and now we're going to be buying mass timber back from them.
Correct.
With
yeah,
our lumber.
that's the problem, right?
Yeah, I want everyone to read Harold Innes, the first supply. Yeah,
Yeah,
this is a Canadian dilemma we have.
Yeah, but I guess, but I mean, like, are we meeting our quotas right now? Like, is there room in what we're foresting now, like in our supply, or sort of on the forestry side, is there enough room to meet some of the demand? Like, like if Element 5 and others are expanding their plants, so they can bump this up, because what we're finding is that we end up sort of importing the wood from Austria and the Finns and everyone else. And they've got it down to a science where they can actually price compete with wood from here. Like,
well, they were using a lot of illegal Russian wood too. We're not going to get into that conversation.
Yeah.
No.
Anyway, I don't know if others want to, again.
Sure.
Let me just another thing about it. The reason why the Finns ask about our wood is they say, why would you take the best structural wood you have, spruce, pine, and fir, and use it in a 2x4? Why wouldn't you use it in making large-scale structural things that wood is? And why don't you take all your cheap wood, the beech we do nothing, all our hardwoods we turn into cigarette paper to put on MDF in terms of that. When Aaron showed me that block that's made from hardwood, what was the compression rate of that block, or that the strength of that?
That was beech, right? That was
beech, yeah.
It was one that I experienced
in Germany. What the cool name?
Experimental lab was 25 megawatts.
NVL.
It was 25 megawatts. Concrete.
And the other one is LVL, which is, again, hardwood layers and other things like that into very strong, plywoods that can be used in element design. We don't do it here. So this is some of the challenges that we're facing just because of a historical and cultural attitude towards the forest. I don't even think we're even at our yields in most of our forests, are we not, in terms of some? What?
Yeah.
Less than half, yeah.
Yeah, we have surplus wood, but as foresters, we're very concerned about the future of wildfires. We're very concerned about how we manage all our crown lands. So the idea of growing a mass timber industry carefully is something we're very concerned about.
And you could get me railing about this, but I will say the one thing. Biogenic carbon is one thing. So taking carbon from one location, moving it to another is saving carbon, but you have to replace that carbon. So, 1/3 of our forests in Canada probably should never be touched, leave the caribou alone. 1/3 of our forests have been harvested at least twice in their lifetime. They should be re-harvested and remanagement. And the whole of Southern Ontario, which was all forest, all the abandoned land that's not in agriculture should be reforested. And then we would have a more sustainable industry. Gotta shut up.
Okay, the only thing I would say, I think it's not about a question of wood fiber supply. We have wood fiber. It's the infrastructure that we don't have. So Haley mentioned it. In Ontario, we're allowed to harvest about, I think, 20 million, I don't know if it's hectares or meter cubed, it's one of those, and we're only harvesting 13, so less than half.
Yeah,
so
it's 24, it's 24 million cubic meters.
Thank you. So we have the fiber, we just don't have the infrastructure, and it's cheaper in sourcing it from Europe because the way that they manage their forests, it's plantations. Here, we manage our forests to regenerate the natural ecosystem, and I mean, I'm not a forester, so I can't speak to that as an expert, but that's my understanding of it. So we have completely different practices. So it's the infrastructure that we don't have.
All right. So we're kind of significantly over time, but if there's any maybe one last question that's life-changing or anything, or even just a good question.
Hi, so we know that the fire test in Ottawa succeeded, and insurance rates are still high. And I've heard that it's not about the fire anymore, it's about the water. So when a standpipe blows up in a building, which is unlikely, but if it does, and the place gets flooded, what does it take to ensure all that mass timber absorbing and warping and buckling? So is Canadian Wood Council coming up with certain tests or ways to sort of address that and, quench the thirst of the insurers on what they can do next, running out of excuses?
Yes, that's true. So water claims in general are the most expensive insurance claims out there, they make up the most of the insurance claims that exist. So I think in any type of building, insurers are getting increasingly worried about water leaks from sprinkler systems or dishwashers in the final stages of building construction. And obviously, wood is particularly vulnerable to moisture. I think if buildings are designed and detailed well, and water isn't hidden or trapped or sitting in wood for long periods of time, wood is really good at drying out, and as long as it's not getting a huge amount of warping or deformation, as you mentioned. So I think catching it quick is the key. And what we're hearing from insurers, again, across all materials, is that they're having a hard time agreeing to underwrite anything that doesn't have leak protection or leak detection, and automatic shutoffs in it for residential projects specifically, because that's where you see the most of the issues. So yeah, leak detection and automatic shutoffs is going to be a big thing. And also just having moisture management plans from the onset of construction, making sure that every trade on site knows where the shutoffs are, making sure that you have plans for if there's a rainstorm when nobody's on site, are you getting people on to go squeegee off the water? So yeah, I think from an insurance perspective, you can do all these strategies for moisture mitigation that will convince insurers to underwrite these projects. And with the premiums, it's really just a matter of data. We need more projects to keep getting built because there's uncertainty in what the amount of the claims will be. There's very few mass timber buildings relative to other types, and even fewer loss claims that have happened. So there's really just uncertainty in what they're underwriting. So that's what inflates the premiums. So I think, yeah, having all of these good strategies up front for fire and moisture and any other kind of risks is very important. And it's important to talk to your broker, talk to someone who's experienced in mass timber and knows what they're looking at. But yeah, I think ultimately it's just a matter of getting more and more of these projects going and getting the claims data to back it up.
Okay, so we're done for the evening. I'd really like to thank Michael, who has organized this like a trooper in doing this activity. I'd like to thank Dialogue. We at the Mass Timber would do anything for Craig, so you might see us more frequently than you might like. No, this is awesome, and just it's really important that we start to participate in the kind of legislation and political frameworks that are actually dealing with this as Canada as a kind of resource-based country, and the type of architecture that's going to evolve over this. And I think that there are people, like we're trying to in school, students are getting more interested in construction and building and these issues because they're living in this. If you have any, my children are all in their 30s, so they look at me and go like, will I ever be able to afford a house in Ontario? And they all have good jobs in there, and they say we can't save money fast enough to meet down payments. So these are going to be really issues that we face. I think mass timber has a role to play in it. It's not the only role. And the missing middle is obviously a very important aspect of that. So thank you very much, everybody.
Thanks, everyone. Thank you to our speakers. Everyone grab some more food before you head out. There's still lots left, and thanks for coming. Thank you.
Now you're coming? No, I didn't. That was only thing on me. Great job.
How long is your drive back?
I got like everyone. How's the bedtime? It's like terrible. You go to sleep. Jesus, I sleep on the thing. This is mine.
Yeah, nice.
Hi. Natasha, hey.
How are you?
Good, how are you doing? Yeah, nice to meet you in person.
Oh,
Thank you so much. Good.
great presentation.
Oh, thank you so much. Thank you.
Absolutely.
Absolutely.
How did the rest of the conversation go?
It was really great. Sure. Like, sure, it's very great, very great resources with me. And we will talk a lot of conversation. So really great. Really. Yeah. We should talk about design for this assembly. I know you're really interested.
Wow. I'm also